the Geothermal Resource Council, one of the resources available to you here in your course. Click on that link, we get you into the Geothermal Resource Council. Great source of information here. You can see here where there's I'm going to file through. U.S. California Restoration Project will enable Cal Energy to drill for geothermal resources beneath wetlands. And this one really kills me right here. 100% of geothermal power is located in the 13 western United States. Hey, we know that's not the truth, because with enhanced geothermal, with EGS, you can drill and get it anywhere. Now, close to the surface, yes. But this is a great source of information. 2 new power plants, units, and significant. Okay, let's go back one. November 9th, 2015. Does Montserrat's volcano hold the key to its future? Multi-million-dollar tests carried out by the Icelandic experts indicate promising potential to power the British territory using geothermal energy, volcanic energy. Okay, and you can see that's relatively current. It's a great source of information. You get down in here, you can look at the geothermal library. See about transactions here. Different acquisitions. So there will be some questions in the future in regard to this link, and we'll talk about that specifically when the time comes. Now the student membership in the GRC, Geothermal Resource Council, individuals with current ID cards from accredited institutions just pay $5 for a year of GRC membership. Membership application form, more information. Membership advantages include access to GRC annual meeting, GRC bulletin, GRC membership roster and registry of geothermal services and equipment, online GRC library, education program, and the International Geothermal Association membership, which would be get you going on your certification for professionalism.
Stanford University.
My name is Sarah Pistone. I'm a reservoir engineer at Calpine, and I got my master's from Stanford in 2011 with Roland Horn in the Geothermal Research Group. For me, it seemed like energy was a really important topic for our world these days, and so I picked geothermal specifically because it appealed to my previous skills as a geologist. The reason why the geothermal program is particularly appealing is you get a really fundamental skill set that applies to multiple fields. All of the theory and modeling work that I learned in school does get applied here. We have a computer model that we use to model our entire reservoir from underground all the way to the surface. And then we have wellbore heat loss models, deliverability, and these are all things that I learned at Stanford. And then on the lab side, you're fiddling with stuff, you're doing fittings of small piping, and that's relevant here, is just a larger scale of that.
6.5-inch diameter.
I like working in a field that I support at a fundamental level, and it's also an amazing operation, and we have over 300 employees. We have operators that work around the clock, 12-hour shifts, and mechanics and techs, and so just to be a part of that whole development is a really, really neat thing.
So take a look at this resource, if you would, please. The GRC, Geothermal Resource Council. Publications. See, a lot of this stuff's pretty well dated. They get up here with the geothermal global solution for $50. You can't look at it if you're a member. Sure you can. But a resource for you to consider. GRC, Geothermal Resource Council. So if we take a look at one of those resources, is fracking for enhanced geothermal systems the same as fracking for natural gas? Geothermal wells are traditionally drilled in where there's hot rock close to the surface, but as you know, it's possible with EGS to create fissures in the rock and inject water underground. This process can transform many potential sites into working geothermal wells. Identify your site. Create the reservoir, microseismicity. You listen. Which is better? Will the public tolerate the blasting and the explosive type of seismographic research, or would they rather have microseismicity, where they actually use small sensors down the hole? And you create the reservoir. And this is where the earthquake issues that they're talking about down in Oklahoma, and that we looked at in the USGS earthquake page, the United States Geological Society. We looked at their earthquake page, and we looked at that specifically in regards to the fissures in Yellowstone. Power plant operation, reservoir maintenance. That's what she was talking about as far as siltation, salts, other problems with piping and deposits. Power plant operation and reservoir maintenance can be expanded by adding additional production and injection wells. And if you have the proper size for your reservoir, for your power plant production, so you're not putting too much cold water back down the hole or taking too much hot water out of the top, then it's there's no obsolescence rate on the resource. So is it the same as natural gas? Well, what do you think? Natural gas, you get the gas out, the gas is gone, and you cap off your well and move to a different location. With EGS, you recycle, don't you? So you recycle your fluids through the hot rock and generate more steam and then generate more electricity. So if it's properly sized, properly maintained, your resource has a very low or maybe even zero obsolescence rate. It doesn't wear out. Take a look at another resource that's available in the central column of your Moodle course.
Hi, I'm Meg Sean here at the Geothermal Energy Expo in Reno, Nevada. Here with me today is Paul Thompson of Ormat. Welcome, Paul. Nice to be here.
Very nice to see you again.
As a major geothermal developer, what is your project pipeline looking like in the U.S.? What are some hot spots for development?
Well, Ormat has a pretty elaborate project pipeline. We're looking specifically at projects in California and Nevada, and we're really in extended exploration phases. What's neat about the geothermal industry that's different, I think, than you find in wind and solar is that exploration takes a lot of work and a lot of man hours, and so we've been doing exploration for quite some time. So we have a pipeline of projects in the exploration phase that we hope to prove up and get online and delivering commercial power in the near future.
Okay. Now, what type of technology do you guys use for geothermal resource assessment? I've been walking around the show and I saw the DOE has a new program that they're trying to compile all the data for resources. Will you guys be using stuff like that? And
Absolutely. You know, our position is that resource assessment is one of the most important things you can do in increasing your chances of developing a successful project. And so we take very seriously this idea of how do you prove the resource to its fullest extent before you make the capital investment to try to purchase the power plant or start negotiating power purchase agreements and so forth. So we utilize almost every tool in the toolbox, if you will, for resource assessment, from MT to all of the work DOE is doing and looking at innovative drilling techniques, slim holes, core holes, ways that we can drill cheaper, quicker.
Got to keep an eye on some of those, Department of Energy, those are some of the acronyms that we'll be using.
Quicker and find out as much information about the reservoir as we can before we make the larger commitment to go into exploration wells that are a huge capital commitment.
Now, before you even start drilling, what kind of certainty do you guys need to really develop a certain area?
What we typically do is when we procure land, we have an idea of what the thermal gradient's going to be and so forth. But before we get into any position of starting to negotiate a contract or so forth, we get almost all the way to production wells to get to the idea of what the flow, the heat, and the permeability of the resource is. Anything prior to that, you're really guessing. And we've really learned, from our 40 years of developing geothermal power plants and having over a gigawatt of generation around the world, the key is to really not to limit as much of the guessing as possible. And so, really our focus, and what's neat about the GRC is all of these technologies are looking to do that. These vendors that are all around us are saying, how can we help you know exactly what you're working with before you make the large financial commitment of putting a power plant in place or negotiating a 20-year contract.
Okay, now, though areas in the U.S. look promising, what are some up-and-coming regions that look good for development? There seems to be a lot of focus on maybe Latin America, Africa. Where are you guys looking?
You're absolutely right. Ormat has a gigawatt of generation around the world, and we actually have equipment in about 71 countries. But right now, the emerging markets for us tend to be Central America, Africa, and we're also looking at places like Indonesia and New Zealand, where we're seeing a lot of interest and a lot of commercial development of the resource that allows us to move in quickly and put equipment in place.
Now, where do you see the industry going in the U.S. without incentives? Are you still going to move forward with new technology like EGS or low temperature projects? How viable are these technologies without incentives?
Great question. I think the incentives that the government put in place to stimulate projects really helped us look at projects that had very tight margins. They were either low temperature or smaller than we would typically have tried to develop if those incentives weren't in place. So I think when those go away, you're going to see a commitment to what we just talked about, which was really focusing on the resource and finding resources that can justify the financial commitment on their own without the incentives. And that also allow us to provide a viable product in a marketplace. We can't increase people's rates too high or anything like that. So you're going to be seeing the future development of higher temperature resources, larger resources, and then the technologies like EGS will hopefully help us develop those projects economically. We have a couple projects, what we call in-field EGS, which is looking at, can we look at old wells that we drilled that weren't productive and see if we can stimulate them or create permeability so that they can be viable wells in an existing project? Or can they help a project that, instead of having multiple wells that cost millions of dollars not producing power, can we go back and, for lack of a better word, tinker with them to make them a productive part and drive down the cost of the power plant? So absolutely, those technologies and innovative drilling techniques that let us get deeper, cheaper, are going to be key to the future of geothermal projects.
Okay. All right, well, thanks so much for talking to me today. And enjoy
My
the rest
pleasure.
Of the show.
Thank you.
So you can see that this is based in large-scale power generation, where this course has more emphasis on what's available right under your feet. More on the GRC. Here we go.
Hi, I'm Meg Sean here at the Geothermal Energy Expo and GRC annual meeting here in Reno, Nevada. Here with me today is Steve Ponder, Interim Executive Director of GRC. Thanks, Steve, for being here.
Thank you.
So the GRC really has an international membership. Where do you see big markets for growth and really up-and-coming areas?
There are several areas, several such as
Buffering issues, eh? Excuse me.
Chile, Turkey, Kenya is growing quite rapidly, and also Japan, which has been quite active in geothermal in the past, seems to be making a comeback.
Now, GRC has a big mission to educate, and you guys have had some great sessions here. So where do you see the most demand in sessions? Is it technical sessions or policy, finance, big projects?
Most of the thrust here is technical sessions, and there's a large group of people that are very interested in that. And it's quite exciting that we've got a lot of students that are here, and we have over 100 students from various universities, and they're sitting in a lot of these technical sessions and seem to really be enjoying it.
Mm-hmm. Great. All right, and now, what does the industry really need to move forward? You guys have got education covered, and you're really working hard on that. But you also have this big tent philosophy. Do you mind describing what that is and why the industry needs it?
Sure. I mean, we're a small industry, and what we like to do is when we move forward is to include everybody in the industry. We have different parts of the industry that are more focused on things such as the education, which is us. Another parts of the industry focused on lobbying and governmental affairs, and we just want to all work together and push the ball forward and get things done.
Now, how can you go about doing that and getting everybody together?
I think that having meetings like this, where we have people from the whole industry and all over the world, we've got over 32 countries that are represented here. I think
buffering issues. Let's go ahead and look at some.
It's going to be over.
Yeah, okay. Let's go ahead and look at some of the larger scale companies. One of which is Ormat, probably the largest company based in Israel. Israeli company.
For more than 40 years, Ormat has been a world leader in developing and operating commercial, environmentally sound electrical power utilizing locally available energy resources. As the world seeks alternative, sustainable energy, Ormat continues to respond with innovative solutions that are smart, affordable, and tailored to meet the needs of each unique project. Ormat's record speaks for itself, demonstrating again and again the reliability and durability of our designed and patented power systems. From tapping the Earth's infinite heat supply to recovering waste heat, Ormat has successfully produced clean electric power to benefit our world. Ormat is a vertically integrated geothermal and recovered energy-based equipment, services, and power provider. This means we design, develop, and manufacture the key equipment used in our plants, and also own and operate power plants consisting of our own equipment. Experience gained in all aspects of power production gives Ormat a competitive edge. Whether you're looking to install a power plant as a self-construct project or seeking a full-scale power provider, Ormat's breadth of expertise provides the most efficient and timely solution to meet any customer needs. Headquartered in Reno, Nevada, Ormat specializes in the development of locally available energy resources into state-of-the-art environmentally sound power plants. We have successfully delivered clean, reliable, and sustainable energy in remote locations to more than 71 countries on 6 continents. Ormat has delivered more than 1,000 megawatts in power systems worldwide. Geothermal energy is a clean alternative to polluting fossil fuels for successfully producing electricity. Unlike intermittent renewable energy sources such as solar and wind, geothermal produces energy 24 hours a day, 365 days a year. Most Ormat power units and power plants installed remain in service today, even those built more than 31 years ago. The Ormat Energy Converter is the benchmark for clean, reliable, efficient energy. With more than 70 U.S. patents covering Ormat's proprietary know-how, we remain a globally recognized leader in our field. In the past decade, Ormat has engineered more than $1 billion in projects. Our breadth of expertise range from supplying utility-sized power plants to developing and owning an entire power plant for long-term power production. Ormat has developed many unique collaborations with U.S. and international partners alike. One of our strategic partnerships involves Nevada's state utility, NV Energy. The collaboration has opened a new frontier in bringing geothermal to the forefront of utility energy development.
NV Energy's relationship with Ormat has been many years and has been very strong. We believe that geothermal power is an excellent source of energy, and Ormat is the best in the world at doing it. Ormat is separated from other developers in the geothermal industry primarily by the track record that Ormat has. It has the ability to deliver what it says it's going to do and do it on a timely basis. Geothermal is a very difficult proposition. You have to find the resource, you have to drill for it, you have to make sure that the temperatures that are in the reservoir are sufficient for producing geothermal power. So it's a very difficult process, and I commend Ormat for how they've been able to accomplish that. But they also have a technology in the power plant itself that is unique in the industry and makes it far more efficient. And it's just been a very interesting relationship that we've had over several years, and now even a closer one.
Ormat had a significant impact on the geothermal and recovered energy sectors in the United States and internationally in 2008. North Brawley. Ormat reached the final construction stages of our North Brawley geothermal plant in 2008. The plant, located in the Imperial Valley, California, will have a generating capacity of 50 megawatts.
The project has been very special to Ormat. It represents a huge effort from Ormat and also our stakeholders in the valley, the regulators and decision makers, the local farmers and the local populace has been very supportive of the project.
Our operation philosophy is basically staff the plant during the daytime, and then at night everybody goes home, we lock up the gates, we turn on the security system, and it's monitored from our Heber 2 control room. It increases the amount of monitoring that we can actually do by putting in the equipment that we need to look at all the fine details and keeping the plant optimized.
This project development schedule was made possible because of Ormat technology. Our discovery well a little bit under 24 months ago gave us a certain set of characteristics from the resource, and we were able to take the Ormat technology in a very compressed schedule and cater it to that resource. And this is a challenge. The geothermal industry, each project, each resource gives you different characteristics, and you have to be able to turn to technology that's flexible, easily designed and quick to the market or quick to the project site to build those plants to put them online.
The project is in startup phase and expected to reach commercial operation in mid-2009. Alkaria 3. By the end of 2008, commercial operation of the Alkaria Phase 3 expansion began in Naivasha, Kenya, and added 35 megawatts, bringing the project to its target capacity of 48 megawatts. The project currently accounts for 6% of Kenya's total energy production. The electricity generated is sold to Kenya Power and Light Company under a 20-year power purchase agreement. Romatsi. Ormat announced the successful co-production of geothermal power at a producing oil well in 2008. This project marked the first of its kind by providing on-site fuel-free power that will increase the productivity and possibly extend the longevity of existing U.S. oil fields.
Cogeneration and then repurposing. We're going to talk more about that, huh? We already talked about it. It's where we take and use the exhausted, fracked it out reservoir from oil and gas, and then use the heat at that depth to run a binary generating process.
Ormat, in a joint project with the Department of Energy at the Rocky Mountain Oil Test Center, validated the feasibility of proven technology already used in geothermal and recovered energy generation for the production of commercial electricity using hot water produced during the process of oil and gas field production. The project, conducted near Casper, Wyoming, uses an Ormat organic Rankine cycle power generation system to produce commercial electricity. Blue Mountain. Another significant project that Ormat has successfully executed is also in Nevada, at the Blue Mountain Faulkner 1 power plant. Ormat's responsibility is to supply and construct the 49.5 megawatt power plant.
Nevada Geothermal Power is a relatively new geothermal development company. We currently have 4 projects under development. The Blue Mountain geothermal project, which is located near Winnemucca, is the furthest along. We expect to be operating that power plant later this year. Ormat is our engineering, procurement, and constructor, the EPC contractor, as we call them. They will be supplying the power plant design, procuring all the equipment, and installing it for us. Ormat basically won on 2 reasons. One, construction schedule was better than the other product, and the efficiency of the Ormat plant on our wells. The wells produce more megawatts utilizing the Ormat technology.
Ormat has already completed the engineering and design, as well as procurement of certain plant components. The electric power generated by this project will be sold to NV Energy under a 20-year power purchase agreement. Under this project, Ormat guarantees completion of the project no later than December 2009. For our dedication to the power of innovation, we are most proud of the values we have preserved over the past 40 years. Ormat is known in the industry and by our customers for living up to our commitments. We pride ourselves in ensuring our projects reach their potential through reliability, availability, and profitability.
To us, it looks like a regular old power plant. It produces 24/7. You don't have to count on the sun shining or the wind blowing or battery storage to be developed. It's a power plant to us. It's dispatchable, and we count on it and can count on it.
Ormat is a major player in the industry with an established record. And when you go to borrow money, which Nevada Geothermal did borrow money to finance this project, you can go to the bank and bank Ormat.
Ormat is dedicated to maintaining the highest availability and most stringent standards in the power industry to reinforce our commitment to providing innovative, trustworthy solutions tailored to meet the needs of each and every energy project. Ormat, innovative, powerful technology solutions.